I'm Faye Watson. I am currently the Public Engagement Officer at the Wellcome Centre for Human Neuroimaging, which is part of University College London. Before this, I was at Cardiff University. I did half a PhD, which I then quit. But before that, I did a Master's, which is what I'm going to talk to you about today. So my Master's was all about this amazing plant called Marchantia polymorpha. This plant is, all intents and purposes, basically the tardigrade of the plant world. You can literally tie it in a tube and do it up with no air for 2 weeks when you go on holiday, and it still survives. So I'm going to talk about this plant, which you all probably walk past on a regular basis. Not at the moment, because stay at home save lives. But Marchantia is basically the most amazing plant because it can regrow from just one cell. So you can treat it as badly as you like, but it still comes back fighting. It can produce both sexually and by cloning itself. So, for example, these are the clones. So this is the top of the plant, and each of these little discs that you can see coming out of these little cups is a clone of the parent plant. Now, this is really, really good for when you want to try and genetically modify a plant, because once you've genetically modified the parent, all of the babies will be genetically modified. And that is one of the reasons is that it produces some what are called long chain omega-3 and 6 fatty acids. So these are key in our diet, as we cannot produce them. And your parents probably made you take these yucky capsules as a kid, and that is what was in them. Marchantia produces them to save them from the cold. So in the winter, when they get really chilly, they start producing loads of fats and make themselves really chubby. And this saves them from being caught by the frost and helps them live through really cold temperatures. So this is a light microscopy picture that I took of the top of the Marchantia, and as you can see, all of these individual little discs that are like growing out of what are called a gemma cup are all clones. So basically this propagates really, really quickly, and you can get loads of it in a very minimal amount of time, and hence my title, Attack of the Clones. So omega-3s are really important to many things in your body, including reducing inflammation. It helps with eyesight, brain function, and your nervous system. Fatty acids like omega-3 and 6 make up lipids, which in turn make up about 50% of all of the cell membranes in your body. Now, every cell in your body has a cell membrane, so that is a huge amount that they make up. However, once you stop taking these fatty acids, they don't remain in your system. So when your mum was giving you these capsules, the minute you stop taking them, the amount of fatty acids decreases. And this is because every bit that's taken up into your body is then taken up by the cell and made into cell membrane. So this poses an issue, as omega-3 comes from oily fish and their organs, for example, cod livers. And that's another thing, you would have probably had cod liver oil when you were younger. Fish stocks are depleting so fast. And we wondered whether there was a way to build up the amount of oil that Marchantia produces. So this is some research that was done before I joined in, and what they found is by making the plants really cold, and as I said, that means that they produce more of it to keep themselves warm, you can actually really significantly increase the amount that they produce. However, they stop growing. So this is a problem, because in the time that you have, you then don't produce any oil. So we wanted to do it without going GM, because with that cold induction of the production, what you could do is just go in genetically and cancel out the bit that in genetics that says that it can produce the oil when cold. However, with Wales being a very anti-GM place, and also just wanting to try anything we can before we go to GM, we thought, how can we do this? So cue my accidental discovery in the lab. So when I was doing my undergrad project, I was throwing a whole load of really random hormones onto the plants. These are all plant hormones that help with root growth and shoot growth. And when I was looking on the microscope, I found that when you added a certain hormone called cytokinin, which usually helps them grow shoots, you get a load of chloroplasts. Now in this picture that you can see, the one on your left hand side is kind of before cytokinin. So these and all these little dots that you can see are chloroplasts. And then afterwards, when you add a high amount of cytokinin, you get so many more of them. Now, this is really important because chloroplasts also are full of lipids. And this is because lipids for them are their pigments, which are what attracts the sunlight and how they can turn sunlight into energy. So what we thought is, okay, if chloroplasts have lots of lipids, by increasing the amount of them, can we also increase things like omega-3 and omega-6? So what we did is we did a whole load of experiments where we did different amounts of cytokinin on the plant. We then grew them up to 28 days because that's all it takes for them to get to a very bulky level. And we then extracted all of the fatty acids that and lipids that were in the plant. And we did this by mashing it up and isolating all of the lipids. And what we found is that you could actually really significantly increase the amount of omega-3 and omega-6 that is in the plant. And this is interesting because you can use that in two ways. You can either bulk up these omega-3 and omega-6s to create Marchantia as a kind of salad. It actually tastes kind of rocket-like with a bit chewier. And then that's another sustainable natural plant source of omega-3s and omega-6s. Or you could bulk up the amount the cells produce, and then you can isolate this and you can make it into a pure oil that you can then sell, for example, in capsules or in oils that you add to food and such like. The other really cool thing about Marchantia is that it hardly takes any input to grow. So Marchantia grows in a thick sheet and it just kind of continually grows out, not up. It requires hardly any sunlight. So when you're out and about on your daily walk, if you go under a bridge or next to some really old walls, you'll probably see it growing in the cracks of the masonry. So it really, really does not need much input to grow. It also is what doesn't need to be upright to grow. So a lot of plants do something called gravitropism, and this is where they're upside down and they will try and grow back up towards the sunlight. However, Marchantia will literally grow wherever it is put. So there is a potential for being able to grow a huge amount of Marchantia in a very small space, upside down, on the sides, and in huge spaces like potentially warehouses. So for example, in the future, what we were thinking is that you could do something like growing on your house, or mainly within like big warehouse spaces, and using really to grow this on a huge scale to be able to scale it up so that we can have a sustainable source of omega-3 and omega-6 fatty acids to save the fish.